Good morning, students. Welcome back to Max class. Exercise 4.3, ninth problem, combination. So, what is combination formula? NCR. NCR is equal to n factorial by r factorial into n minus r factorial. Right? Okay. So, take your ninth problem. A kabaddi coach has 14 players ready to play. How many different teams of 7 players could the coach put on the court? So a kabaddi coach has 14 players. Okay, how many players you have? 14 players. How many different teams? How many different team he can make from the 14 players is the question. Okay, so since we want to make a group, okay, we are going to do combination. So here 7 players must be selected from 14 players, correct? Huh? We have to select 7 players from 14 players. Okay, so this can be done. Okay, that we can write it here. Therefore, number of different teams of players. Therefore, number of different team of players is 14. Out of this 14, we are going to make 7 group. Okay, so this we can write 14C7 and have to do it in a shortcut method without using the formula. From 14, we have to take 7 numbers down. So 14, 13, 12, 11, 8, 7, 6, correct? 3, 3, 6 plus 1, 7. Okay, divided by, starting with 1, you have to take 7 numbers. 6, 7, correct? So, 6, 6, 7, 7. Next, 4, 3, 3, 3, 2, 4, 5. No, 5 we can't cancel. Oh, here I made a mistake. See, I didn't take. Okay, so 14, 13, 12, 11, 10 I missed out. 10, 9, 8, 1, 2, 3, 4, 5, 6, 7. Right? Divided by, starting with 1, we have to take 7 number. 4, 5, 6, 7. So 1 7 is 7, 2 7s are 14, 2 2 cancel. 1 6 is 2 6 are 12. And if we take 5, 2, 3 3s are 9, and 4 2s are 8. That is 13 into 2 into 11 into 2 into 3 into 2, which is equal to 3432. That is 3432 ways we can form a different teams. Okay, now this is your first subdivision. And second subdivision, see the question. There are 15 person in a party and each of them shake hands with each other. So two of them shaking hands with each other. How many handshake happen in the party? So out of 15 people, 2 are combined பண்றாங்க. Okay, so how many we can combine? This is also your combination. So answer is what? 15C2. Okay, now third subdivision. How many card can be drawn through 20 points on a circle? So I'll do this one, third subdivision. How many chord can be drawn through 20 points on a circle? What is mean by chord? What is chord? A chord is obtaining by joining any 2 points on the circle, correct? Any 2 points on a circle. Number of cards drawn through 20 points is same as the number of ways of selecting 2 points out of 20 points, correct? Because total 20 points is given. The 20 point, if you take 2 point only, you will get a card, correct? So hence the total number of card is 20C2, correct? So 20C2, how can we simplify 20 into 19 by 1 into 2? So 10 times, which is equal to 190. So 190 ways we can form a card, right? Now, fourth subdivision. In a parking lot, 100 1-year-old cars are parked. Okay, out of them, 5 are to be chosen at random uh, for to check its pollution device. How many different set of 5 cars can be chosen? So out of 100 cars are there. Out of that 100 cars, we are choosing 5 cars. Okay, so how to do this one? Yes, 100 C5 ways. Okay, this is also for your homework. So answer is that's all. 5 cars can be chosen out of 100 cars. 100 C5 ways. Next, fifth subdivision. How many ways can a team of, that we can do fifth subdivision. How many ways can a team of 3 boys, 2 girls and 1 transgender be selected from 5 boys, 4 girls and 2 transgender? Okay, so out of 5 boys we are choosing 3. 3. Out of 4 we are choosing 2. Out of 2 we are choosing 1. Correct? So solution is 3 boys can be selected from how many boys? 5 boys, correct? 3 boys can be selected from 5 boys in 5C3 ways. Similarly, 2 girls, how many girls? Totally 4 girls. Similarly, 4 girls in how many ways? 4C2 ways. And 2 transgender. 2 transgender in 2C1 ways. Therefore, total number of selection equal to, what is the answer? 5C3 into 4C2 into 2C1. Okay, so according to your book back answer, we have to do it. So your book back answer, they have stopped with this, but still this is a smaller number, no, so we can give the answer. So 5, 4, 3 by 1, 2, 3. 4, 3, 1, 2 into 2. That's all. So this 2 will get cancelled. 3 will get cancelled. 2 will get cancelled. So 5 4s are 20, 3 2s are 6, which is equal to 120. So 120 is your final answer. Okay. Now, 10th question. Find the total number of subsets of a set with hint is given here as NC0 plus NC1 plus NC2 etc. up to NCN equal to 2 power n. Okay, we want to find out total number of subsets of a set. So 4 elements irunda, we are going to find out how many subsets are possible. Okay, so this is easy because hint already they have given answer as 2 power n. We can give the answer directly. What is the first subdivision? 4 elements. 4 elements, correct? Huh? So solution, uh, total number of subsets. Okay, total number of subsets is equal to 2 power n is given in the book. Okay, so we can directly write 2 power n. And what is the answer? 2 power n value is 4 here. 2 power 4. So 2 power 4 is 16. Okay, so suppose if you want to use the left hand side, how can we use total number of subsets equal to 4C0, 4C1, 4C2, 4C3, 4C4. We have to simplify all those things. And finally, definitely what answer you will get? 16. That you can write it directly. So this is your final answer. Remaining 2 subdivisions is your homework. And take your 11th problem. A trust has 25 members. First subdivision, how many ways 3 officers can be selected? And second subdivision, how many ways can president, vice president and secretary be selected? Now actually this is a problem which differentiate the permutation and combination. See your first subdivision, how many ways 3 officers can be selected. So a group of people, 3 is a group of people, right? So group of people, now it is a combination. Now if you see the second one, president, vice president and secretary is a separate persons. So separate person that we are going to arrange. Okay, so this here we can follow the permutation. Okay, so take your first subdivision. How many ways 3 officers can be selected? Okay, so first subdivision. 3 officers can be selected from 25 members. Correct? 3 officers can be selected from 25 members in 25 C3 ways. Correct? So that is simplify panna 25 into 24 into 23 by 1, 2, 3. Correct? So this one if you cancel 2 and this one will be 1 2 is to 7 2s are 14. Correct? Next 2 2s are 4. So 3 and 12 will get cancel at 4 times. So 25 into 4 into 23 which is equal to 2300. Okay. Now second subdivision. How many ways can a president, vice president and a secretary be selected? Okay. So president வந்து out of 25 we can select one. Correct? So a president can be selected from 25 members. 25 members in 25 ways. Next, a vice president. Vice president can be selected from remaining 24 members. Correct? Remaining 24 members in 24 ways. And similarly, and a secretary. And a secretary can be selected in 23 ways. Therefore, total number of ways of selection. Total number of ways of selection is 25 P3, that is 25 into 24 into 23, which is equal to 13,800 ways we can choose the president, vice president and secretary. Now 12th question, how many ways a committee of 6% from 10% can be chosen along with a chairperson and a secretary? So what is question? We are going to form a committee of 6 people from 10 people, okay, along with chairperson and a secretary. Okay, so a committee, okay, a committee must have, who are the two person? Chairperson and a secretary. Chairperson and a secretary. Correct? Okay. That is, these two can be selected in 10 C2 ways. Correct? These can be selected in 10 C2 ways. Okay. Remaining, how many person we have to choose? We have to form a 6 person. 6 ல 2 we have taken. அப்போ remaining total 8 people இருப்பாங்க, but we have to choose 4. Correct? So remaining 4 persons for a committee can be selected from 8 persons. 8 person in 8C4 ways. Is that right? Okay. Therefore, number of ways of selection of the committee. Selection of the committee is 10C2 into 8C4. That is 10C2 na 10 into 9 by 1 into 2. 8C4 na 8, 7, 6, 5 by 1, 2, 3, 4. So 2 5 times. Here 4 2 times. 2 2 cancel. Here it is 2 times. So this, if you multiply, you will get 3150 ways. Next question, 13th one. How many different selections of 5 books can be made from 12 different books? So totally how many books are there? 12. How many books we have to select? 5. But some divisions are given. So your first subdivision is 2 particular books are always selected. So out of 5 la, we are always choosing 2. Correct? So how many we have to, remaining how many we have to choose? 3. That's all. Okay. So your first subdivision is 2 particular books are always selected. So remaining will be 3 books, right? Remaining 3 books can be selected from 10 books. Totally 12 books there. 12 2 already selected. So remaining 10 books in 10C3 ways. That is 10C3 equal to 10, 9, 8 by 1, 2, 3. And if you cancel, 3 3s are 9, 4 2s are 8, 12, 120. 120 ways. Now, second subdivision, 2 particular books are never selected. So, out of 12 la 2 never selected. அப்போ totally எவ்வளோ books இருக்கும்? 10. Out of 10 la we have to choose 5 books. That's all. That is your answer. Since 2 books are never selected. Since 2 books are never to be selected, the selection of 5 books from 10 books, 5 books from 10 books in 10C5 ways. That is 10, 9, 8, 7, 6 by 1, 2, 3, 4, 5. 2 times, 2, 2, 3 times, 4 to 8 times. Okay. Again, if you cancel, multiply everything, you will get 252 ways you can select the 5 books. 15th problem homework. Now take your 16th question. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly 3 aces in each combination. So here how many cards we are going to pick? 5 cards. And that 5 cards, what the condition is given? 3 aces should be present. Okay. So now in a deck of 52 cards, how many ace will be there? For totally how many ace card will be there? 4 cards, right? Okay. So out of 4 cards, how many we are choosing? 3. And totally 52 cards are there. 52 la 4 aces. So how many will be remaining? 48. So 48 la how many cards we have to take? 2 cards, right? So see the solution. In a pack of 52 cards, there are 4 aces. Right? Now, therefore, number of ways of selecting 3 aces from 4 aces. Totally 4 will be there. We have to pick only 3. That is equal to 4C3. Correct? Next, what is the thing? Number of ways of selecting remaining 2 cards, right? Totally 5 cards we have to pick. 5 la 3 is and remaining is 2. Okay, ma? So 2 cards out of 48 cards. That is equal to 48C2. Okay. Therefore, required number of ways is equal to 4C3 into 48C2. That is 4C3. How can we simplify? 4, 3, 2 by 1, 2, 3 into 48 into 47 by 1 into 2. All will get cancelled. 2 2s are 4, 4 2s are 8. That is 4 into 24 into 47. That is 4,512 ways. These ways we can choose the number of 5 cards from 52 cards. 17th question. Find the number of ways of forming a committee of 5 members out of 7 Indians and 5 Americans so that always Indian will be majority in the committee. What is given? There are 7 Indians and 5 Americans. Okay, so we have to form a committee. We have to form a committee of how many members? 5 members with majority Indians can be. Okay, majority enna irukano? Indians. Majority Indians can be formed by the following ways. Okay, now look at here. Now, Indians. How many? 7. Americans, how many are there? 5. Last will be a combination. Now, what condition is given that Indians always should be majority. So, number total evlo peoples we have to select 5 people. Okay, we'll start up with 4 Indians. If we choose, we have to choose 1 American. If we choose 3 Indians, we have to choose 2 Americans. We cannot choose 2 Indians because நீங்கள் இங்கே 2 போட்டிங்கன்னா இங்கே 3 ஆயிடும். But always Indians will be a majority. So all 5 will be Indians, na 0 Americans, right? So you can write this as out of 7 we have to choose 4. So 7C4 into out of 5 we have to choose 1. Similarly, out of 7 we have to choose 3. Out of 5 we have to choose 3. Next 7C5 into 5C0. So if you simplify this, that is your final answer. Therefore, total number of ways of forming the committee. Forming the committee is, we have to add up all those things. So that is 7C4 into 5C1. 7C3 into 5C2 plus 7C5 into 5C0. So 7C4. So 7C4 we can subtract this using one property. 7 la 4 pochuna 3. So we can write this as 7C3 into 5. 5C1 is 5 plus 7C3 into 5C2 plus again idana cancel panamna 7C2 to get the smaller number avladha, and 5C1 value is 1. Again if we simplify this, 7 6 5 by 1 2 3 into 5 plus 7 6 5 by 1 2 3 into 5 4 by 1 into 2 plus 7 6 by 1 2. So if we cancel, 1 3 is 3, 2 3 are 6, 2 2 cancel, again 3 2s are 6, 2 2s are 4, 3 2s are 6, right? So 5 5s are 25 into 7 is 175 plus 350 plus 7 3s are 21, which is equal to 546 ways. So 546 ways we can choose we can form a committee. Now 18th question. 18 is your homework problem. 19th problem now. 7 relatives of a man comprises 4 ladies and 3 gentlemen. His wife has also 7 relatives. 3 of them are ladies and 4 gentlemen. Okay, so totally husband, wife and husband are there. Husband he have 7 relatives. Out of that 4 ladies and 3 gentlemen. Similarly, wife has 7 relatives. Out of that 3 ladies, 4 gentlemen. Okay, in how many ways can they invite a dinner party of 3 ladies and 3 gentlemen? So totally they have to invite 3 ladies and 3 gentlemen, so that there are 3 of men's relative and 3 of wives relative. Actually this is a combination, that is we have to combine the people and we have to get the answer. Okay, now I'll make the tabular column, that will be easy to understand. Now see the different possible arrangements. Okay, so totally how many people we have to choose? 3 ladies and 3 gentlemen we have to choose. Totally 6 people we have to choose, correct? Okay, and one more condition is also given. What is that condition? 3 of men's relative, 3 of wife relative. Okay, now here look at here. This is ladies, that men. So ladies and men. This is your husband, wife. Okay, now in husband, how many ladies are there? 4 ladies are there. In husband, how many gents are there? 3 gents are there. Wife, how many ladies? 3 ladies, 4 gentlemen. Okay, number we have to choose totally 6 people. 3 of ladies and 3 of gentlemen, 3 of men relative and 3 of wife relative. Okay, now I'm choosing husbandless 0 ladies and wifeless 3 ladies. Now, wife la 3 ladies I have completed. Now I have to choose 3 gents definitely from husband relatives. So 3, here it will become 0. Okay, first combination completed. Next, second one. If I choose 1 lady here, I have to choose 2 lady from wife. If I choose 2 gents here, if I have to choose 1 from wife. Similarly, 2 women, 2 ladies from husband, 1 ladies from wife, or 1 gen from husband, 2 gen from wife. And what is the next possibility? 3 0 0 3. Now using this tabular column only we are going to do the problem, that's all. Therefore the required number of ways, therefore the required number of ways we have to combine all those things, that's all. That is 4C3 into 4C3. Okay, now look at here. Wife la how many ladies are there? Okay, and this one will be, so to avoid confusion what we can take as husband, wife, ladies, gentlemen. So 4 ladies, 3 gentlemen, 3 ladies, 4 gentlemen. Okay, now using this one, wife la 3 ladies are there. Okay, so wife la 3 ladies, out of 3 we have to choose 3. So therefore the required number of this is, out of 3 we are choosing 3. Next, husband order gents, husband order gents is 3, so 3 we are choosing 3. Okay, we completed. Plus next one, husband order ladies how much? 4, so 4 C1. Next, husband order gentleman 3 C2. Similarly, wife for the ladies, 3 C2, wife for the gentleman 4, so 4 C1. Similarly, next this one, out of 4 C2, 3 C1, 3 C1, 4 C2, plus husband order ladies, 4, so 4 C3. Similarly, wife for the gentleman, is 4, so 4 C3. Now again, C3, 3 C3 is 1, 3 C3 is 1, 4 C1 is 4, 3 C2 is 3, 3 C2 is 3, 4 C1 is 4, plus 4 C2 is 6, 3 C1 3 into 6, 4 C3 would answer 4 into 4. So if we multiply this, 1 plus 144 plus 3 24 plus 16, which is equal to 485. So 485 ways we can arrange this. We can get the relatives of 3 men's relative and 3 of wife relatives. That's all today's session. Complete the homework as I given already. Thank you, students.